Episode 20, Philosophy of Classical Physics. What is the methodology? Two paradigms of physics. Let us consider the things of nature which can be divided into two classes, namely inanimate things and living things. For our present talk, we would treat the bodies of living things separately by excluding the aspect of life. Then these bodies also would be included in the class of inanimate things. Strictly speaking, it is possible to divide the totality of inanimate things into two levels called atomic world and subatomic world. The atomic world is the upper level and it is constituted by matter as the stuff or building material. In the atomic world, the unit of matter is atom. Then atoms are like the bricks of a house. Scientists have discovered over 110 varieties of atoms, differing in weight and other properties. But atom is minutely small and is unobservable even by the most powerful microscope. Additionally, there is another entity called energy or force, which is required for the formation of things as well as for the motion or activity of things. We may state that energy or force is normally defined as the ability to do work. In this manner, the things of atomic world are constituted by matter and energy. This is the area of classical physics. Next, consider the lower level of inanimate things. This is the subatomic world to be studied by quantum physics. Now we may combine the upper and lower levels of inanimate things. The totality is conveniently designated as physical world. Additionally, any constituent of physical world is treated as a physical thing. We can distinguish between the areas of classical physics and quantum physics as illustrated by a diagram given below. The development of classical physics happened during the period of 16th to 19th centuries. The most important scientists of this field are Copernicus, Galileo, Kepler and Isaac Newton. They used physical variables like place, time, distance, force and speed to formulate laws regarding the movement of planets and physical things. The scientists of classical period accepted the view that the world moves due to definite physical laws and hence it is like a machine. This is called mechanistic worldview. The method of classical physics is to combine mathematical concepts and sensory observations to formulate the mechanical laws pertaining to nature. This mechanistic view reached its zenith when Isaac Newton discovered the laws of motion and the laws of gravity. In 20th century, the principles of quantum theory were discovered regarding the constituents of matter. It is the beginning of quantum physics, which is another topic altogether. Now we are entering the subject designated as philosophy of science, which started in the context of classical physics chiefly by Descartes, David Hume and Immanuel Kant. Here the two most important philosophical problems considered are given below. 1. What is the method to determine the validity of theories and laws of classical physics? 2. How does classical physics answer the vital question about the origin and existence of things? It may be noted that the first question pertains to epistemology or theory of knowledge, while the second is about ontology. When we say that this table exists, it means that we have knowledge about it. Hence, epistemology and ontology are interrelated. This principle is adopted in the following paragraphs. As introduced earlier, epistemology has four stages called methodology, source, justification and truth. In view of the principles stated above, we would take methodology and source as actual parts of epistemology and we would reserve justification and truth to be explained under ontology. We have already stated that every cause-effect relation or scientific law is formed by a process involving five parts, namely theory, hypothesis, deductive conclusion, testing and inductive inference. These 5 parts would constitute the subject matter of methodology. It is explained below. Theory. The main theory adopted is atomic theory, giving the properties of atoms and molecules of substances. It includes relevant and important concepts like space, time, mass, weight, temperature, pressure and motion. Next is the stage of hypothesis. It is clear that the unobservable entities like atoms assumed in the theory cannot be subjected to experimental study. By hypothesis, we mean a set of assumptions adopted for a particular experiment, and these are formed by expressing all concerned theoretical entities in observational terms. To cite an example, the concept of mass is unobservable. Hence, mass cannot be brought within the experimental scheme. In this situation, mass is measured using the notion of weight, which is an observational concept related to the gravity of Earth. The premise of theory and the facts of hypothesis are combined logically in order to derive a conclusion. In this context, the deductive conclusion is alternatively called a testable statement, which is usually expressed as an equation. A testable statement is subjected to experimental verification in the testing stage. It involves the designing and conducting of experiments repeatedly and collection of data. Such sample data are subjected to analysis using statistical techniques. If experimental data confirms the truth of the deductive equation, then it is accepted. The scientist has to generalize that chosen equation is applicable to all places and times by specifying the experimental conditions. This is the process of inductive inference. Accordingly, the proved equation is said to have universal validity. In this way, it becomes a scientific law pertaining to the population of instances of the phenomenon. We have already named the 5 parts of methodology together as TYHDTI scheme. An example of classical law obtained in the above method is water boils at 100 degrees centigrade when heated under specific atmospheric conditions. Thus, we conclude the topic of methodology here. In the context of classical science, there was a raging controversy related to methodology as well as the philosophy of mind or source. It is called Rationalism Empiricism conflict. Descartes is the founder of modern philosophy as well as of the doctrine of rationalism. Here, philosophers equated human mind to the supernatural being called soul. Then the physical laws are mathematical formulations involving intuition and deductive reasoning. It does not give the stamp of validity to experimental or empirical observations pertaining to induction. The opposite approach, namely empiricism, holds that all kinds of scientific propositions are produced by inductive method using sensory data. Even the deductive propositions are also derived from previous observational data. The main articulation of empiricism was advanced by David Hume on the basis of the materialist philosophy of mind or source. As per the foregoing, there is no ground for reconciling between these two positions, namely rationalism and empiricism. Intellectual energy of philosophers in classical period was spent mainly upon this debate. The said problem persists in the present century also. Now we can anticipate that its solution would be reached through our innovative system philosophy. The remaining topic of existence of things, that is ontology, is postponed to the next video. Please subscribe to this YouTube video series. Thank you for watching.